Hi, this is Vishwesh, and this is my development walkthrough for Unreal Blueprint assignment. So, like looking at the editor, this is my scene area, and here I have all my game objects listed, and then I have my content folder here. So now let's go into light blueprint first. So we have this little blueprint. So if we look at this is an third-party external fab light which I imported from Unity, Unreal Fab Store. If we go into the event graph of this blueprint, so we have these two little scripts functioning here. So one is to take the keyboard input L and then toggle the visibility of the light. So this turns on and off the light based on the input. And then we have one more script, which is a box collider. So this collision components enables and disables the help prompt, which just indicates to press L key to turn on the light. So whenever there is an interaction between the player object and the light, these scripts get fired and we see that this helper function gets triggered. And then we have this construction script here. So this construction script executes initially and sets all the visible parameters of the object for the light blueprint. So it gives the user ability to set the light color of his wish and the intensity of his wish. Now let's have a look at another light blueprint. So all these both of these are class blueprints, so they can just be dragged into the gameplay and we can use them. So we have one more light blueprint here. So this light blueprint also has a room kind of structure into it, and we have a point light inside. So this is an automatic light, so it get triggers whenever a player gets in the area of the light. So whenever the player enters into the room, this light turns on. Whenever the player leaves out, it just turns off. So it's again a box collider which is attached to the visibility of the light, and the target is our point light. So whenever the player gets in contact or enters the room, we can see that the light turns on, and whenever the player leaves out, we can see that the light turns off. Now let's look at a few door blueprints. So if you go into the doors folder, we have the blueprint. So we have two doors again, which is a manual door and which is an automatic door. So let's look at the automatic door first. So this is an automatic door. Again, this is a fab which is downloaded from Unreal's Fab Store, and we have a box collider around it just to get the interaction with the player. So if we look at the event graph, whenever there is an interaction with the player and with the box around the door. So this starts a door timeline. This is just to door timeline is to have a smooth transaction of the door from position X to position Y. So we are going to change the Z-axis position of the door, which slides up from the ground. So whenever there is an interaction between player and the door collider, it moves the position based on the timing. So if we go into timing, we have these 2 points. So at 0 time it's at position 0, and at 2 seconds time it's at position 250, which is above the player, and then player can walk in. So whenever there is an end of overlap, the script is fired in reverse, so that door comes from top to bottom and just closes. And then let's look at the second door blueprint. So this is a manual door. So this is again, so it's a door and a frame which is again borrowed from Unreal's Fab Store. And we have a similar timeline here from 0 to 1 second. So initially at 0 time it's at 0 position, and at time 1 it's at position 1. So in this, it's not a sliding door, it's a rotating door. So So as it is a rotating door, we are gonna move the door around the z-axis to have a effect of opening and closing. So whenever the door open script is triggered, it comes into this flip-flop and checks the current status of the door. So if it's closed, then it plays the action from start. If it's already open, then it reverses the action, and this goes into this alpha, and it gives like a smooth transition instead of sudden opening of the door. And then we set the new axis, uh, new z axis, so it rotates around the z axis. And we also have this little widget or a prompt script attached to the door. So this comes whenever the player character comes in contact with the door or with the contact with the collision box around the door. So this checks for the player, and then it gives or it activates an interactive variable. So this interactive variable is the prompt which we'll discuss later. So this interact variable gives the command for opening and closing the door, like which is press E on the keyboard to open or close the door. So if we look at the interact prompt, so this is the interact prompt. So it's a simple prompt with canvas. So it just displays press E to interact on the screen whenever the player comes in contact with the door. And this door works with line trace. So that line trace it's attached to the third person character. So if we look at this, we have this door open and close here. So whenever we press key like E on the keyboard, this line trace gets triggered, and it gets the position of the main camera from the global axis. And then whenever this line trace is triggered, the out hit goes to this block, and then it checks for the actor. So if the actor has a tag door, which is our actual door, then it casts that into the door blueprint which we earlier discussed, and then it calls the door open function from that blueprint. So this ultimately calls the door open function here, the door open function from this blueprint, and the sequence flows. Now let's look at the animation blueprints. So we have this longbow animations which is imported from Mixamo, and we also have this character which is downloaded from Mixamo itself. And then we have all these animations here. So we have jump, stand, run, run back, run forward, run left, walk back, walk forward. So like we have all this bunch of animations here. And we can see all the animations listed down in the asset browser. So if we look at the event graph of this animation class, animation blueprint class, so at whenever on the begin play we are getting the character reference. So this is the third person character which we are using in our game. So we are getting the reference of that character to apply animations on. So on animation updates, we are doing this stuff. So we are checking for the valid character. So if it's a valid character, then we are getting the velocity and we are setting the speed. We are getting the direction and we are setting the direction of the player. We are getting the jump factor, so which is either the player is falling or not, to apply jump animations, and we are setting the jumping variable here. So if we go into, so this is the animation graph animation. So it has a state machine. So based on the state, it applies the output animation. So if we look into the state machine, we have these four states. One is entry, so it's a start point, and we have ideal state where player is doing nothing and standing still, as we can see on the left side. We have jump state, and we also have walk and run state. So now let's look at each state quickly. So we have this ideal state. So from the animation asset which we downloaded, we just attach the standing ideal animation as the output. So this is the result of it. And then we have walk and run state. So we combine both walk and run using a blend space. So if we look into the blend space, so it has a speed time, like a speed axis from 0 to 600. So based on the speed of the player, we can animate either walking or running. So if we normally use WASD keys, the player will walk. If we hold shift and we use the keys, the player will run. So at the start point at 0, we attach the walking script, and then at the end where the speed is maximum, as the speed increases, we increase the movement of the player. So we can see as the speed goes up, the player runs. So this is the output of the blend space, and we use this blend space attached to the player as the speed animation here. So as we got the speed initially from the event graph, we pick up the same variable here, and based on the speed, we are animating the position of the player. And then we have jump here. So this is the jump animation, which is again separately downloaded and then attached to the skeleton. So whenever we hit a space bar, we see that this jump animation gets triggered and we can see the player jumping. And then we have all these transaction blocks here. So based on these rules, the transactions happen. So whenever speed is greater than 1, this transaction enters, and then walk run animation gets triggered. And when speed is less than 0.5, then it again comes back to ideal state. And then if we have jumping as true, it goes to jump state, and we can see the jump animation. And then when we have jump as false, so here we are checking it. So if it's false, then this block makes it true, and then we move down to ideal state again. So this is the brief development workflow of Unity's Unreal, and we can see the output in the gameplay video. And these are all the assets which are like class blueprints which we attach. So here are the lights. So here is the room inside which we have a point light, and then we have a player with animations here.